These are some of my favorite problems, these tangent line problems. In order to tackle them, though, we need to know how to find the equation of a line. And there's two things that you learn from Algebra 1 that you need. And those two things are, one, you need to know the slope of that line. And two, you need to have a point on that line. Remember, in calculus, we were using y minus y1 equals m times x minus x1. So for example, if I knew that the slope of this red line was m equals -2, and this was the point right here, 1, 4, I could write my equation as y minus 4 equals -2 x minus 1. And I've written the equation of the line. All right, so let's do this problem. This is actually a problem from the AP calculus exam. Not from this year, but from a previous year. Let f be the function defined by f of x equals 4x cubed minus 5x plus 3. Which of the following is an equation of the line tangent to the graph of f at the point where x equals -1? Well, we know what 4x cubed looks like. It's one of those S-curve functions, and we're trying to figure out what's the slope of the tangent line at that point so that we can get the equation of the line. So what are the two things we need to know? Well, the first is going to be slope. How am I going to find slope at x equals -1? Well, slope is just the derivative. So I'm going to take f prime of x. I'm going to take the derivative of this, and I get 12x squared minus 5. Well, I want to evaluate that at -1. I want to know what the slope of the tangent line is at -1. So I get f prime of -1. Well, that means I'm going to plug in -1 here. And that gives me 12 minus 5, which is 7. All right, the next thing that we want to do is we want to find a point. Well, we know x is equal to -1, but what is y equal to? Well, this is, if you're finding the point, you have to use your original equation and plug in -1 into your original equation. So this is going to give me 4 times -1 cubed minus 5 times -1 plus 3. So -1 cubed is -1 times 4 is a -4 plus 5 plus 3. So that gives me 4. So my point is the point -1, 4. Okay, just to emphasize this again, the slope comes from the derivative, the point comes from plugging into the original equation. All right, so now let's go ahead and let's write this in our point slope form. So we're going to have y minus y1, which is y minus 4, equals m, which is 7, and then it's going to be x minus -1, or x plus 1. So I'm going to erase all this, and then we're going to go ahead and see if we can get this equation, which I would accept this as a final answer for sure, but we're trying to solve this multiple choice question, so we're going to have to manipulate it. So give me a second to erase all this. All right, I've erased it. So now let's go ahead and just do distributive property here. So I keep my y minus 4 equals 7x plus 7. And now I'm going to add 4 to both sides. And that's going to give me y equals 7x plus 11. Now let's just take some time now to see what this looks like on Desmos. All right, so here's the S-curve that I was talking about. And what I have is my point x equals -1, and of course that point is -1, 4. We found that by plugging into our original. So I went ahead and I graphed our answer 7x plus 11, and you can see that that is in fact the tangent line at that point x equals -1. Awesome. So our final answer is C. All right, let's try another one. Find where the tangent line is horizontal on f of x equals 2x squared minus 4x plus 1. Then write the equation of the line. Well, we know that this is a happy face because it is a quadratic. Where would my slope of the tangent line be horizontal? Well, that would be located right here at the vertex. What is the slope of a horizontal line? Well, that would be a slope of m equals 0. So if I want to find where this is, I need to take the derivative. I need to find the slope. So our first step, as always here, is going to be to find the slope. That slope is going to be f prime of x is equal to 4x minus 4. Okay, now I want to know when the slope is 0. I want to know that x value because in the previous problem it told me the x value. Here it didn't, so I actually have to solve. So I have to set my derivative, my slope, equal to 0 because that's when I have a horizontal tangent line. So I'm setting this equal to 0. I'm adding 4 to both sides. I get 4x equals 4. Divide by 4. And I get x equals 1. So this point right here has an x value of 1. But remember, I also want to find a point. Okay, well, that comes from my original equation. I'm going to take my 1 and I'm going to plug it in right up here. 2 times 1 squared minus 4 times 1 plus 1. That gives me 2 minus 4 plus 1, and that gives me negative 1. So that's a negative 1. All right. And so it now wants me to write the equation of this line. So that's going to be y minus my y1. Well, y minus minus 1 becomes a y plus 1 equals a slope 0. That's my slope is 0, and then x minus 1 because of this right here. And if you want, we can go ahead and we can kind of distribute this, but I would accept this as a perfectly good answer. This would be a y plus 1 equals 0x, and then minus 1 times 0. Well, 0 times x minus 1 times 0, that just becomes, all of that becomes 0. Then I get the equation y equals negative 1 because I'm subtracting 1 from both sides. And that makes total sense that this flat line would be the equation y equals negative 1. All right, for the following function, find the exact answer for the x value of the points where the tangent line has a slope of negative 1/9. This problem is a little easier in terms of the amount of steps you have to do because it's just looking for the x value. It's not looking for an equation. It's just looking for the x value when the tangent line has a slope of negative 1/9. And it's interesting that it said points. Maybe there's more than one answer. So when does the tangent line have a slope of negative 1/9? Well, let's find the tangent line first. To do this, let's rewrite y as x to the negative 1, and you can see that our tangent line is going to be a negative 1 x to the negative 2, which I can rewrite as negative 1 over x squared. So I want to know when this tangent line has a slope of negative 1/9, so I'm going to set this equal to negative 1/9. So let's go ahead and now cross and solve. So that gives me a negative x squared equals a negative 9. Let's divide by negative 1. Negatives cancel. I'm left with x squared equals 9. Square root both sides, and I get x equals plus or minus 3. So there are actually two places where the slope of the tangent line is negative 1/9. And I want to go ahead and confirm this on Desmos. Let's do it. All right, so here is my graph of 1 over x. You should recognize that from pre-calculus. And here are the two answers that I found, x equals negative 3 and x equals 3. So I put in my slope of -1/9, did my point slope form, and you can see that this is in fact a slope of -1/9. Okay, that blue line right there, you can see the slope right here. And same thing here, this one also has a slope of -1/9. So we have successfully found the x values, x equals -3 and x equals 3, where the slope of the tangent line is -1/9. Thanks for watching, everyone. Be happy.